Hello, today we're working on Lesson 10, and this is Introduction to Classifications, which means types of solutions for equations in one variable. We're eventually going to get to equations that use an x and a y, called linear equations that we make graphs from. And so right now we're just working with one variable. That's why you see that word. Here's our goal. I can solve an equation and decide whether the equation has one solution, no solution, or infinitely many solutions. And just a quick correction, that should be the word an equation. All right, so I will let you know that today's going to be a little bit of a long lesson. Again, it's introductory. We're learning something brand new. And I want to try to explain this as best I can because I know this is a new concept. So up until this point, when we solved an equation and found one and only one solution, the solution may have looked something like this. X equals 8, negative 12 equals n, y equals 4.5. So our answers could be positive, negative, they could be rational, meaning a fraction or a decimal. So one solution means we can find a singular number that will make an equation true. In other words, there is one number we can substitute for the variable that will make both sides of the equation equal. The module calls this a unique solution. So let's explore this concept. So this tells us the solution to the equation below is x equals 4. Substitute it for the variable. Both sides of the equation should be equal. So instead of solving the equation, we're going to substitute this. We're going to take x equals 4 and we're going to replace all the x's with 4. So let's start this. We're going to start with 8, and where I see an x, I'm going to write 4. So 8 times 4, and then minus 7 equals 3 times, again I want to replace the x with 4, and that would be, then I add 13 to it. So it's the same equation, we just don't have a variable any longer because we believe that the solution is x equals 4. So when I take 8 times 4, I get 32 minus 7 on this side, and 3 times 4 on this side would be 12 plus 13. So 32 minus 7 would give us 25, and 12 plus 13 would also give us 25. So that solution, x equals 4, is true, and it's the only one number that can make both sides true. If we tried to fill this in with a different number other than 4, then the two sides of the equation would not be true. So I'd like you to try the next one on your own. This time, we're substituting a equals 5. So please substitute a where the, 5 where the a is. So after you substituted and then multiplied the coefficient times 5, on this side we have 22, and on this side we have 22. So once again, this is an example of when we solve an equation and get one solution, that's the only number that will work. So down at the bottom it says, as it turns out, there are 3 types of classifications of solutions, or types of solutions. Most of the equations we will work with will have one solution. However, some equations will have no solution, and other equations will have infinite solutions, meaning all real numbers can be substituted for the variable, and both sides of the equation will remain equal. So let's explore that. On page 20, it says no solution means that we cannot find a number that will make an equation true. In other words, there is no number that we can substitute for the variable that will make both sides of the equation equal. When we try to solve this type of equation, the solution might look similar to these examples. We might get 2 equals 8. That's nonsense. The 2 doesn't equal 8. Or negative 3 equals 5. Well, we know that's not true either. So first, let's solve the following equation. Next, we're going to choose a solution and substitute that value in the second and third copies of the equation below. So you're going to notice they're all three the same. We're going to solve, and then we're going to try to pick a solution and check it just like we did on the front of this sheet. So we're going to build our wall. I see a term with variables on this side. I see a term with variables on this side. We usually try to eliminate one of the terms with variables. And we usually go after the weaker one, but you can see they're both the same. So it doesn't matter where I start. I'm going to start and I'm going to take away this group of 3x's. And so if that's what I did on this side, I have to do exactly the same thing on the other side. So when that happens, both of them eliminate. And on the left side, I have positive 4. And on the right side, I have 7. And now I have an untrue statement. 4 does not equal 7. When this happens, that's an indication that there's no solution. So let's just randomly see if we can find a number that will work. So I'm going to randomly pick the number 10. And so I'm going to substitute in my equation 3 times 10 plus 4 equals 3 times 10 plus 7. And when I do this, I'm going to get 30 plus 4 over here and 30 plus 7 over here. But you can probably already see they're not equal because 34 does not equal 37. So I'd like you to choose a number, any number you want, because we don't have a starting point. It just says 4 does not equal 7. Would you choose a number and substitute it here and continue once you've done that? So once you did that, you came up with a solution that was not true. One of the sides did not equal the other side. And I would probably guess that many of us chose different numbers, particularly since we're not together. So why do you think that is? What is causing this not to be true? Well, if you look, this term is identical. So no matter what we put here, this part will always be the same if we use the same value of x, which we have to. We have to substitute the same number in both x's. However, we're always going to be adding 4 to it on this side, but on this side, we're always going to be adding 7 to it. So that makes sense, and it's never going to be equal. So this is an example of no solution. So when we see something like this, it means that there's no solution. So let's try our next situation. Infinitely many solutions. That means that any number will make an equation true. In other words, we can substitute any number for the variable, and each side of the equation will be equal. When we try to solve this type of equation, the solution might look similar to these examples. 3 equals 3. Well, that's true. Negative 11 equals negative 11. Well, that's true. So again, we're going to try to solve this first equation, and then I'm going to choose a number for this one, and then you're going to choose a number for this one. So I'm going to solve it. So let's see what happens when you solve this type of equation. Again, we're going to start with the variables, and I'd prefer to start with a weaker variable, but I see that they're both the same. So it doesn't matter which side I start with, but I'm going to eliminate plus 5x by taking minus 5x. And I have to do the same thing on the other side. However, I really didn't have a weaker variable because they're both the same, which means they both will eliminate. And on this side, I'm going to be left with positive 6. And on this side, I'm also going to be left with positive 6. And this is a true statement. 6 does equal 6. So at the end, when I get a true statement, that means that any number will solve this. So I'm going to choose any number. I'm going to start with an easy one, like 2. So I'm going to fill in my x on both sides with 2. I'm going to start with 5, and I'm going to fill in 2 where the x is. And I'm adding 6, and on this side I'm starting with 6, and I'm adding 5 times negative 2. So that would be 10 plus 6, and over here it's going to be 6 plus 10. So once I fill that in, of course these two sides are the same. They're 16 and 16. So I randomly chose 2. So now would you randomly choose any number you want? Would you go ahead and fill it in for x? It has to be the same number on both sides. And when you're done, start the video again. So no matter what number you started with, I'm confident, as long as you use the same number, that you had a number that equaled on both sides, and it was exactly the same. And this is an example of infinite solutions. And sometimes they call it infinitely many solutions, meaning that any number, and we could have used a fraction or a decimal. And when we work with this, we're going to see that when we solve it, these two numbers are the same because the term with a variable eliminates. When it's no solution, we're going to see that these two numbers are different, and that's not a true statement. And we're able to eliminate both of the terms that have variables. Now, when we work with equations that have one solution, generally speaking, the term with the variables are different. So now let's go and look what we're going to be asked to do today. So we're going to do one together, and I'll have you try it. The directions state solve the following equations and identify whether it's one solution, no solution, or infinite solutions. So I'm going to start by building the wall. Then I see a term with a variable on both sides. I see negative 3x here, and I see negative 3x here. So they're identical. I'm going to choose to take away, or excuse me, eliminate one of them. So I'd have to eliminate this one by adding 3x. Now, no matter what's on the other side, I still have to do exactly what I did on this side, which would be adding 3x. My solving step always has to look identical on both sides. It so happens that it eliminated this one and it eliminated this one, leaving me with 6 equals 6. Well, this is a true statement. My variable disappeared. I no longer have x equals something. And this is an indication when the numbers are the same that it's an infinite solution. So we're going to go ahead and circle infinite. That means any number I could replace where the x is, and both sides would be exactly the same number. So I'd like you to do that one more time. One solution, we're going to get x equals a number. No solution would be something like 4 equals 7. And infinite solutions, we get something like 6 equals 6. So please go ahead and try the rest of them, and I will post the key later. Thanks so much, and enjoy your afternoon.